Welcome back to Daily LeetCode. We are back once again. As you can see, I'm wearing the shirt is called the Catkin because it's a kraken that's actually a cat, or the crack kitten. Legendary merch. Maybe we should do merch. Maybe this is merch. No, I'm lying. I bought this at a buffet. So we're back once again. We have some comments as per usual. We have a comment. It says by Gentiru. Actually, let me switch. Comment by Gentiru. What's your LeetCode username? My LeetCode username is the same as the channel name. So this would be my page. Real ones will recognize what this icon is from. Real ones will know, but the real one, others may not know. But this is the page. I haven't done many problems, right? In the beginning, we were doing a bunch of mediums, right? We had like a bunch of easy solved. Now, last 2 weeks, we've just been doing easies. So, hoping to get this bar to filled, and then that would be pretty cool. And yeah, I think there's always a thing with these things. Yeah, I think there's definitely the consensus that I think people should do, like, what did they say, like 30% easies, 60% medium, and like 1 hard or something like that, or something like that. And I think that definitely is the case if we're trying to extract maximum value in terms of like balancing time and outcome. But I think I'm just trying to build a long-term habit here, so not really in a rush. Plus, I think there's the general consensus that easies are built up of concepts from mediums. Medium is just 2 easy concepts put together, and then a hard is maybe a couple of medium concepts, maybe plus an easy, that make a hard. And I think we've definitely seen that. There's so many mediums where like you'll do it and it's just like you're combining like 3 or 4 easy problems together. But yeah, just trying to keep it palatable. So yeah, I would say this is my LeetCode. So yeah, next question, 042. You should definitely code live. This is from System Design Begins. Legendary video, by the way. We realized that the system design keyword is unbalanced. So YouTube is going to have to nerf that keyword, but it's an unbalanced keyword. And yeah, I think in that video I mentioned thinking about coding live. Maybe doing like 1 day a week where we just all code together. We just do some LeetCode together. Could be cool. Could learn from each other. Exchange decision trees. Could be cool. So yeah, I still consider that. There's so many things that have to be done. So many things that have to be done. So I have to make the 100 days LeetCode video, and I'm working on something else. But yeah, we definitely should. We should do something like that. I'm saying that like it's not me who's stopping us from doing that, and it is. So I should definitely figure that out. I find it extraordinary how in the end the solution was so short and simple for the binary watch. True. So yesterday's video we were doing a problem called binary watch, and I wrote a very complicated solution, which was kind of combining it. That was, like we said earlier, combining a few different easies together to make a solution. But yeah, the actual solution, you know, or the much better one, it was just very simple. You know, we're using 11 and 6 and 59 as a proxy for the binary, and then converting it to binary, counting the ones that it turned on. So very clever, and we'll remember that for future problems. So yeah, it's just always cool to see, and that's why I think the easies are so much to get out of them. I don't know how to explain it. I feel like the easies, you don't get a lot of value quickly, but over time I think you get some good value. But who knows, maybe in a month after doing easies we'll say this is torture, but we will continue nonetheless. But yeah, very true. And yeah, Botea Public, this man has a way with words. There's just a way. I find it extraordinary. It's just an incredible like preamble for a sentence. And then we have Niall Mashiek. I'm not sure if I'm saying that right. I totally feel you on the losing something part. That's why we adore people at the top of their fields. True. Think of athletes, musicians, mathematicians, etc. That being said, I still think there is a huge difference between artists who can portray their creativity by themselves and people who just use AI for art. True. It's like a mathematician calculating some hard equation and someone just Googling the answer. I see what we're getting at here. Also, since you have more experience than I do you think it's worth for me to work for free to gain work experience? I have a company that I'm sure they would take me as an unpaid intern for 3 months. I don't need the money since my parents pay for my rent and expenses. This pains me to say. Hey man, that's how it be, man. There's nothing wrong with that. It's just how it be. I don't have any coding or tech work experience, so would that 3-month internship give me a huge advantage afterwards if I apply for a junior position? Well, I am a junior, or I guess I would still be considered like software 1. But yeah, I think there's I'll say, you know, what I went through. I mean, I remember getting my first job after college. I think I sent out like 600 applications. So I was sending out like 60 applications a day. I think I had some good resume projects, and I had just finished the master's at the time. The competition was just very steep. Just seemed impossible to get a foot in the door. Out of those 600 applications, I heard back from like 14 of them. I think 4 of them actually wanted an interview, and then I only got 1 offer. So yeah, the numbers are just really tough, and I know especially if you're going. Let me see. You just said it works. Yeah, it always depends. Like if you're coming straight out of school, you know, maybe it might be easier to get in, but maybe not by a large amount. But if you're coming from a boot camp, it may be unpaid. May be the way. I know someone who did unpaid for a little bit, and they're killing it now. But yeah, sometimes unpaid is kind of a way to get in the door and just like say like, oh yeah, I have a year's programming experience or a couple of months or something, and it's like, you know, you just look really good even though you didn't get paid. But it's like, you know, suffering. It's like you're paying something early on, like your time. It kind of balances out. It's kind of a weird way to look at it, I think. But company takes you on. They have no idea if you can do the work, but they're not paying you. So it's like, we'll give you experience, and hopefully you'll give us, you know, some value if you can pick up the stuff quickly. But if the internship is like technical and programming, I would say might as well. Like it's tough. It's really tough even to get internships. Like I remember after school, even after I'd finished, I was like, okay, couldn't even get a like regular job, like a regular software job. I was like, oh, I'll apply to internships, and I couldn't even get a call back. In retrospect, I understand now why. I was applying to internships at like big tech companies, and you can apply for internship as pretty much as anyone, basically. You don't necessarily have to be in school. So you might be applying for an internship, and you're competing against people who have degrees or who already have a year's experience, and they just want an internship at a specific company. And it's just very, very difficult. It's very, very difficult. And so, yeah. It's difficult. So if it's technical in your program, I would say maybe try and look into it, because if you could get that experience, that could be pretty cool. But if it's not technical, if it would just be like, because I did an internship, I did one internship that was just like general like office and clerical work, and that ended up not helping me in terms of tech jobs, unfortunately. So it depends, but I don't have all the answers to this stuff. I'm still a noob myself, but maybe that gives me a little bit more confidence there, because I do feel like there are people who like. I feel like there are people who have been working now. Hey, this is Niall's channel, but I can't go back. I feel like there are people who have been working now, but they haven't been in the job market in a little bit, and the game has just completely changed. I remember when I used to apply for internships back in like 2018, the ball game was just different. Now it's like the people you're competing against, like it's crazy in like in any field, especially with, you know, COVID and remote work. Now, you know, when you applied to a place, you were just competing against people in your, you know, like your local space, maybe a 50, 100, maybe 250 mile radius. Now, you know, you could be competing with people from Nebraska, people from Kansas, people from Philly, people from Ohio, people from Iowa, and it's just like on Indeed, you can see like when you submit an application, it's just like, I remember I was looking on Indeed. And sometimes you might find a job, right? And it'll be like just posted or new or hot, like someone just posted it, and it literally just had like, it already had 400 applications, and I was like, the person reviewing all these is not going to review all of them. And it's just like, It's crazy. So if it's technical, I would say definitely it's gonna make you look. It's gonna make you look good, especially if it's technical and you get to program, and you also get like a this is, I think it's kind of how it'd be sometimes. You get like a transference of credibility. It's like, oh, another company took you on, so they've already vetted you, sort of. If we take you on, I feel more comfortable taking you on because it's like, oh, another company already took you. It's kind of like it's like you've been, because of your previous experience, you kind of been pre-vetted. But yeah, it's really difficult. But yeah, for the people, yeah, it's just really difficult. So it is really difficult. I would say if it's technical and you get some programming and like some experience in there and it's unpaid, I would say go for it. It's 3 months, but it might make the job search much easier. But yeah, always tough though. I'm not, I don't know exactly the situation, but just from the top, high level, I guess that what I might be say as a novice myself. But yeah, in terms of the art thing, yeah, we definitely lose something, man. And I think the half of it is the journey and the technical skill. Like now we can create AI art in 2 seconds, but you lose the whole 40 years of getting to a level that, you traded your life or a great deal of suffering or commitment or hardship to achieve this. It's what gives it value. It's like, I think we all know the thing where it's like, oh, if someone gave you something random, like someone gave you a $60,000 car, you'd be like, oh my God, this is so cool. Thank you so much. You just wouldn't value it as much as if you grinded yourself and traded your life for it. Not your life, but sometimes it'd be like that. Like, I think that's why people always say stuff like they treat their things better than stuff they give, that they treat their own things better than stuff that people give them, because you don't have an attachment. It's like you don't feel it's hard to explain. I don't really know. I don't want to pretend to get it either, but it's just tough. And I think we definitely lose that. Like we can all create AI art in 10 seconds, but we don't really we can create 400, 500, maybe 1,000 pieces in a day now, and all of them, nothing really mean anything. They don't really mean anything to us. But now, like when Kim Jong-gi drew, or an artist draws, they might be the only person who likes this piece, but they are in love with it. It's a special part of them. Their identity, just in the mere act of it existing, the lines itself, their identity is wrapped up in just in the mere existence of it, because it's born out of like the suffering of the person. So it's just different, I feel like. And those drawings, even though they might just spend 2 weeks creating one drawing, it's something they always look back to. It's very like quality over quantity, I guess. Besides the point, we are here for LeetCode. And speaking of quality over quantity, we're not going for quality anymore. We're going for quantity, okay? We're going to do all of the LeetCode easies, hopefully extracting small amounts of quality by excavating large amounts of quantity. So we have gone full business person. We are going to mine all the LC easies. So hide your LC easies, and because we're coming for them. So I'm going to talk less from now on, because we are exactly at 13 minutes, and I think we were quoted last video as going 320% over. We're going to not do that. It's too late. We already did it. So we're going to code now for an hour for suffering. We're not going to suffer for an hour. And yeah, so we're going to get into it. Yeah, we're just going to code. And then we have other things to do. So let's get started. But before we get started, one could say it's impossible to start without joining the hyperbolic coding chamber. That's how I feel. So you're going to want to join the hyperbolic coding chamber to find the easiest way to solve your LC easies, your LC mediums, and your LC hards. So you're definitely going to want to do that, because I'm in the hyperbolic coding chamber, and I am being mentored by some of some of the greatest algorithms to ever exist on the planet. So you're going to want to join for those tips and cheat codes. And yeah, we're just going to jump into it right now. Okay, So here we are. Given the root of a binary tree, return the sum of all left leaves. Okay. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. A left leaf is a leaf that is the left child of another node. So basically, we want to get the sum of all left leaves, right? That's all the nodes. A leaf is a node with no children. So the greater subset would be 9, 15, and 7, which have no children. We want only the left leaves. So the left node would be the node that's to the left of the left subchild of the current node. So we only want 9 and 15, which would give us a sum of 24. That is interesting. That is interesting. Okay, and it looks like the number of nodes in the tree is in the range 1 to 1,000, so it looks like our answer can range from 0 to anything, basically. And with one element in the tree, we return 0 because there's no left leaf. The node is a leaf, but it's not a left leaf, right, because it has no parent. So I think there's a way to go about this. I think we can solve this with a general depth first search, or honestly you could solve it with a breadth first search as well. We're gonna with DFS because we don't have a native implementation of a double-ended queue or linked list in Ruby, so we're gonna go with 3. If we do in order, so in order first, a depth first search, we're gonna do a iteration pattern that's gonna be based on the relative ordering of the current node, the left subchild, and the right child. So in order is gonna be L, N, and R, so we'd visit left, right? Doesn't really matter. We're at left, and then we have 9, right? No children, so no point in counting it, right? Then we go up to 3, right? Since we're at 3, we say, okay, do we have a left child? And is it a left node? This might be a little different than I thought. I thought we could do L and R. So you go L, N, right? You can't go L, N, or R here, so we go back to 3, and we say, okay, N. Now for N, we check 9, and we say, does its child have no children? Does its left subchild have no children? No, so we could add it to our running sum. Then we would go to R, which is 20, right? We'd go to L, 15, right? There's no L and an R. We go back to 20. We check, okay, does our left leaf, is our left subchild a leaf, right? And if it is, we could add the sum. So maybe this could work. And since our value is going to be, since we're trying to what we're trying to calculate is a sum, I think addition is commutative, which means that the order of the operations doesn't matter. So I think we could do this, but I think we would have to use a trick, right? Because we need a way to propagate the sum throughout the... Actually, let's try it 2 ways. We'll try it with the trick. We need a way to propagate the sum throughout the whole tree. But with recursion and returning, it can be difficult. So we could just keep a reference by just having an object that would map to... This is actually going to be a hash in Ruby, I think. Oh, no, it would be an object. It's going to start at 0, and this would work by reference. And then we could call a recursive function, which we'd pass in root and values. And so from here, I'll minimize this. Call it sum leaves. It's going to take a node, right? And let's just call it object, because that's really what this is. And so from here, we have the object, And like we just said earlier, we're gonna do L, N, and R. But first, right, we want to make sure that the node actually exists. So say if node, right? I think we're fine with saying if node. And then we're gonna do L and R. So we could do sum leaves node.left object. Then when we come out, we're gonna say, okay, is our left child, right, is node.left does it exist, right? And is it a leaf? You say and node, right, dot left, right? So we'd be at we're basically at 3 here, right? We say node dot left, we get to 9. We basically want to know, is the node a leaf, right? We know that, right, just by simply asking a simple question for a node: does it node dot left and node dot right equal nil? We could simplify this even further by just saying is leaf and passing in a node, right? If it's not, we can just say, okay, return node, and we use a safe navigation operator, that left equals nil, and node ampersand not right equals nil, then it's a leaf. So we say if node dot left and is leaf node dot left, right? Then we'll say object dot sum plus equal node dot left dot val, right? And then we want to do L and R. We'll go right. So if we check this, we're passing in sum. It's going to have a value of 0 to start. We're going to sum the leaves, starting with the root with the object. 3 does exist, so we're going to go sum leaves node dot left. Well, now we're at 9 with sum leaves. 9 does exist, right? But you can't go left and you can't go right, right? And node dot left doesn't exist, so we can't call is leaf, right? So then we go back to 3, right? And we're here at 3. We're going to say if node dot left exists, which is 9, and node dot left is a leaf, which it is. We're going to add object.sum. We're going to add node.left.val to object.sum, and then do sum leaves right. Then we go to 20. If node 20 does exist, we go to 15. You can't do anything. 15 is a leaf. I think this should work. Array can't be coerced into integer. Array can't be coerced into an integer. I'm not understanding. A node dot which one here is the array? We're just gonna put object.sum and puts node.left.val. Oh, sum is a method. So we're gonna shadow again. We're just gonna call it value. How about that? So everywhere we had object dot sum, we'll just change it to value. And define method value for maybe you just can't create random values. And then we forgot to return Return object.value. I keep forgetting you can't just do that. Do it like this. So I think this seems to work. It doesn't seem to be too awful. I'm guessing this would run in linear time because we're visiting the entire tree with linear space as well on the stack for each recursive call. Now, instead of using this value object, what if we just did something like return some leaves so we don't have to do this weird value stuff? So here we just return node.left.val. And then what we'll do is return the sum and return the sum of it all together. So we're doing the left and the right. We want this thing in the middle. And what we're basically going to swap in here is the same case, node.left and is leaf. Node.left, right, will give you node.left.val, otherwise it would give you 0. Then we'd have another case where we say if node equals nil, we'll return 0. So we do some leaves, right, with node.left. So basically do some leaves with root, it's not nil, so we do some leaves of node.left. Now we go into node.left, it's not nil. So we go into 9. All right, it's not nil, so we do some leaves node left. Well, it is nil, so we return 0 plus, this is going to have value to false, which is 0 plus 0. Go back to 3, say node.left is leaf. Node.left does exist, and is it a leaf? It is, so we get node.left.val. I think this should work. Or I guess now we could have just declared it all in here. Or we could have just put all of the coding here and here and something like this. And then instead of some leaves, we'll do some of left leaves. It says nil can't be coursed into an integer. this smaller so it's easier to read. Sum of leaves, no dot left, plus no dot. I'm not understanding. Nil can't be coursed into an integer. Where is this problem? Let me just see if this runs. This runs and it's clearly wrong. If I add this back. Yeah, I'm not following. I don't understand. Type errors are so strange. Nil can't be coursed into an integer. What's the issue here? What part is nil that we're coercing to an integer? If I remove this, is this fine? I don't understand how this changes anything. We just moved it out of the... That doesn't make any sense. All we do is move it out. But let's say it's linear time. We didn't have to use the weird reference cheat. So I think this is okay. We spent way too much time doing the extra stuff on that problem. So here we have convert a number to hexadecimal. Given an integer num, return a string representing its hexadecimal representation. For negative integers, two's complement method is used. Oof. So we're given an integer num. We want to represent a string. Return a string representing its hex representation. All the letters in the answer string should be lowercase characters, and there should not be any leading zeros in the answer except for 0 itself. You are not allowed to use any built-in library method to directly solve this problem. So for one example, they'll give us 16. The hex representation of this is 1a. I think that's because 1 represents 16 and a represents 10. I think this could work. But it looks like the number can also be negative, which is really interesting. Flip all the bits and add 1. So if we had 26, if you wanted to convert it, I think you could just go iterate front to back with the actual number. Basically, we have a value 26. We want to pretty much, we'll put a number down for anything, or any time a place in the hexadecimal representation can fit into the number 26. And then maybe when it's negative, we can just -1, we'll just flip all the bits and add 1. You get a ridiculous number that you still have to convert, that we'll just do some magic to, and then convert. Okay, well, maybe that could work. So what we'll do is, we're given the number 26, and since it's hex and we're dealing with 32-bit numbers, we'll start and we'll just iterate, right? Starting from power equals 32, right? And we'll start from the, can you start from the front? You can't start from the front because we don't know, we don't have any leading zeros. For example, if we had 26 here, we could have like 7 or 8 leading zeros. We don't have that. We don't have that. Okay, I think we can do this. We'll start at 26, and I think I'm just getting a little bit confused here. We start at 26, and we won't stop until this value gets to 0. And then what we're going to start with is I think we can start with the power at like 7 or 8. It takes 32 bits to represent. We're at 32-bit numbers, but I think you get to that 32-bit max much sooner in hex. So we just want to know basically how many times, starting from the largest numbers that we can create, it goes up, it goes into 26, and that should give us our values, I think. So for example, we have 26, then we'll say while 26 is greater than, not 26, while num is greater than 0, we're going to have a string which is going to start empty, then we're going to have n, and then we're basically going to have power, which is going to start at, let's just say 8, and it's going to work its way down, and then we're going to say This one is confusing. I think I'm experiencing some transference. I'm thinking about Excel column sheet number and Excel column sheet title, which is confusing me. Oh, they're all related though. That's the difference there. The difference there is that we're dealing with base 26. I think I'm getting confused. We have 26. If we were to do sum is greater than 0, why is that? How are we able to iterate in reverse before? It's because we're dealing with bits. And you're lucky because with bits, it's either you're on or you're off. This one, that's not the case. You see, you want to find the largest value that could fit in there, but why haven't we had to write other ones like this? We wrote a base 26 algorithm before. Just converting a base 10 number to a base 26 number. I think this works, but I think I'm just a little confused. I guess I'm trying to fix why I've thought about this in other problems, like why I'm getting confused. Why this is bringing up a memory of another problem, but it's making me like I can't figure out what's the difference. And I think it's because we were dealing with binary, but we did have a base 26 problem which wasn't binary. I don't remember ever having to write something like this. So I'm trying to figure out why that we were writing something like this. For it was also it was a number in base 10 that we were converting to base 26, but it had a weird angle to it. Had a strange angle to it. On 26, we have 1A. I'm certain we could write a solution that might work. The other one was base 26. Because the other one was base 26. The other one was base 26, and we didn't have to count up. We did have to count up, except we did it with mod. No. think we didn't have to count out because we were using mod somehow. I think that's what the answer is. Still, I don't understand. But we'll do it anyway. Basically, want to know the largest number that can fit into the number before we go down to the next power. So we have 2 while loops. I have another while where we'd start, or I think you can do 1 up to and including, but actually we want to go in reverse. We'll do 1 to 16. We'll call it the offset. Then the actual value we'll use will actually just be 16. Be 16 minus offset. So go from 16 up to and including 16. This would actually be the value since we're going from 16 down, we'll say as soon as if value times 16 to the power is less than num, I don't know if they call this value, but maybe it's just 2 different names. There's a specific value that you multiply by the base and the power, and then I guess we could call that, we'll just call this the product. Value times 16 to the power, and if product is less than num, then we're going to want to say num minus equal product, and string plus equal num dot to s, which will have to transform into a base 16 digit, but we'll do that later. And then we'll break out of this loop, which is a little confusing. Yeah, this is very confusing, but then we'll come out of the loop here, and this is where we'll say power minus equal 1. Then we can just return string, but we haven't converted it to base 16 yet or handled the negative. But if we just try it for 26, we should get something like, I think 16 to the 1. Yeah, we should get something like 1. String should say 1. It should say 110, I think. Time limit exceeded. So basically num starts at 26, power equals 8. 26 is greater than 0. So now you go from 0 up to and including 16. We say value equals 16 minus offset, so 16 minus 0. We do value, which is 16 times 16 to the power, which is some really large number, which is not less than num. I'm actually going to do less than or equal to. Not understanding why we're getting 26, 26, 26, 26. Oh, not num. The value. Alright, so we said we should get 110, and this should translate to 26. We can just make another function. Call it 10 to hex. It'll take a string. I don't know if you can actually start a function. Or actually, yeah, we'll just have a hash up here, and it's just we're just gonna set it equal to numbers basically. Where 0 maps to 0, right? The string, and we're gonna have this 25 more times. So we just have to fill this in really quick. We'll say 2, 3, 4, 5, 6, 7, 8, 19, 20, 22. Oh, no. It only goes up to 16. What am I saying? I got confused for a second. And what these map to, I think it's 0 through 9. No. Yeah, I think it's, yeah. It maps up to itself up until 10, which goes to A, I think. Which I'm realizing now we could have just said, could have simplified this, but 10 is going to be A, C, D, E, F. And I guess the 16th symbol is 0. So from here we can just say hash sub value. We're having a lot of zeros. We'll say string plus equal hash if value does not equal 0. Works for the first case. Let's try a different number, like 262. We got 106. Oh, we expected 106. So this isn't what we're looking for either. We just don't want a bunch of extra zeros. We don't want any leading zeros. So if value.length equals 0 and no, if string's length is 0 and value is equal to 0, and we want the opposite of that. So if the string isn't empty and the number I think it just might make more sense to remove it, because I think if we run this, we still get the right answer, just a bunch of zeros. So to switch it up, we can just clean the string afterwards. This is definitely not it. Split it by empty. Iterating through the string. Maybe we could probably lessen this issue by starting at a smaller power. I think there's like 6 possible digits. We'll just do it like this. We'll take the string, we'll split it, we'll have an IDX, which is going to be equal to 0, and we're going to say split dot collect, and we're going to say car, right? Then we're going to say IDX plus equal 1 if car what am I doing? We just want to count up until the first non zero index. We're just going to start at IDX and say while string sub IDX equals 0, we'll do IDX plus equal 1, and we'll return a string dot slice IDX to string dot length. Okay, we have a result. Let me try something else. Somehow case 1 still works, so now we just need to do the negative part. I said negative part is just for negative numbers, 2's complement method is used. So it looks like we just need to flip the bit and add 1. if you flip all the bits here, you get like 2 million something 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 and 0, and you add 1, you get all FFF because it's the upper bound of 2 to 31 minus 1. And then you just run the regular. Is there a simple way to flip all the bits? If you take a number like 26, take a number like -1, we could do bit shifting, we could right shift the bits. If we left shift the bits on num, then we could left shift if we left shift the bits out of num, to reverse bits. I think I actually forgot to reverse bits. We basically just need to implement a function to implement this function, and I think we'd be done. You flip bits. You flip the bits. If we left shift them out, -1. I think I'm out of brain juice. Left shifting the bits. I'm just left shifting them out. We left shift the bits out. Left shift the bits out. Left shift the bits out of num, and then we can create a new number. So you could just add 1 and then shift it. Okay, so I think we can make this work. I have new num, which is equal to 0. We're going to do basically 32 times, and then we'll return new num. I'm gonna say if num and basically we need to check if the bit is set. If the bit is set, we want to flip it. So we're gonna say new num plus equal if num. So basically ternary if num and 1 means the bit is set. We want to change it to 0. It's not set. We want to change it to 1. And then we'll shift this one. We'll do new num equal new num. Bit shifted once to the left. And then we'll do num with the opposite. So we should get something that makes sense. Oh, we have to add 1. If num is less than 0 is the only time we want to do this. Change to 2's comp, by the way. Actually, no, we can just call it flip bits. Let me see if this makes sense. If num equaled 1011, new num would be equal to 0, and then we're saying 32 times new num plus equal num and 1. Well, num and 1 would be set to 1, so we'd say, okay, we keep it as 0, and then we do new num bit shifts. Now we look like this, and then we'd say bit shift num right once. Let me keep the original value. We bit shift it right once. We take that away. Actually, I think it would be like this. Yeah, well, we actually would shift it, so it would be like this. Then we're going to say new num plus equal num and 1. Well, num and 1 is still 1, so we're gonna flip it, which is 0, and then shift it over 1. So shift it over 1, and then we have 0. We say, okay, new num plus equal num and 1. Well, and wouldn't give you 1 here, it'd give you 0, so we're gonna give the opposite. We're gonna get this set to 1, and then shift new num 1 over. And we're gonna have num over and this should become 0. Yeah, we definitely didn't. Something is just off here. How did we get 0, 1, 1, 0? We should get 0, 1. Let's restart. New num plus equal num and 1. Well, it equals 0. Okay. Equals 0. And we get 1. It's like it's just off. Maybe it makes more sense if it starts like this. Num doesn't start at 0, it starts at num and 1. If num is 1, we want to set it equal to 0, or set it to 1. Yeah, I think we just need to relook at this one. This one shouldn't be difficult though. I think we just need some more brain juice, so we'll return tomorrow.